Okay, okay. Okay, hello, hello. Good evening. Good evening. Okay, so in the last class we have gone through the introduction of operation management. Okay, so we will be continuing. We have finished the introduction part. So now we are in the chapter 2.1, that is demand forecasting. If any of you have missed the session, the last class session, you can, follow the Institute YouTube. There's a channel, so you can see the recording over there. Okay, that was just an introduction, so you can follow it from the Institute YouTube channel. So this is our second session of OM, right? Okay, today we will be looking at demand forecasting. Okay. So demand forecasting. Okay. So let us break down what this means. So demand forecasting. So last class we have seen that every company, it either manufactures goods or provides services, right? So it manufactures goods or provides services to make a profit. Okay, so because that is what, so if you go somewhere, you want to buy, you will buy some goods, right? Or you'll get some service. So for the institute, now we are giving you a service. I'm teaching you the class, so that is a service we are providing. So for goods and services. So what is demand forecasting? So what is demand? Demand is very self-explanatory. So demand is nothing but the willingness of the purchaser to buy your goods, right? So the willingness of the purchaser to buy your goods or services at a given point of time, goods or services at any given point of time, right? So now suppose I am manufacturing something today. So how much do I manufacture? So how much will I be able to sell? Right. So that is the demand. So suppose I'm so suppose I'm manufacturing 80 items this year. Suppose you think, but the demand for that is 100 stock. So I am manufacturing 20 less. So I am losing the revenue on 20 items. Right. So we do not want to face such situation. Right. So that is the willingness is called demand. And what is forecasting? Forecasting is nothing but, the prediction. We can call it a prediction or the expectation. Right. So I want to predict what will be my demand in the future, or say for 3 months, in 3 months, or say in 5 months, or for 1 year, right? So that is demand forecasting. So I want to know how much I will be able to sell, or how much the market will consume my goods at a particular time frame. Right. This is demand forecasting. Right. Now, there are many methods for demand forecasting. Before going to the methods, okay, so demand forecasting, we have three types of forecasting. Let me add a new page. Yeah. So there's a time period for forecasting. Okay. There's a time period for forecasting, basically. You have a short term forecasting, right? And you have medium, and you have long term. Right. So how much my demand will be there, you know, based on the time period. We have segregated the demand forecasting into three time periods, right? Short term, medium term, and long term. Okay. So short term. So typically short term ranges from 6 to 8 months, right? And medium term will be for approximately an year, and long term is 5 to 10 years, right? So this time period is like 6 to 8 months, and this is approximately 1 year, and this is a long term period, so 5 years and above, right? Okay, so excuse me. So what falls for what products basically we need a demand forecasting time period. So we can decide, see, if you have innovative products, or products which keep changing very frequently, right? So if you can take your mobile phone as an example. So your mobile phones, you see one model will be not fixed. Now today you have one iPhone 12, tomorrow 13 will come, then you'll get 14, then you'll get 15, right? So for goods, where the life cycle is very small, the life cycle is very less. So as in, this will not be available again in a few years. So suppose in 4 months, if you want to buy this model, it will not be available. So you have to go to the next model. So for that products, you will need short term demand forecasting. Okay, and for medium term, so medium term, you can see most of your capital goods, right? So, air conditioners and all of those things. And for those kind of goods, you will have medium term, demand forecasting. And for goods, you will be needing always, right? So your household goods, like with the things we use daily, like, we use soaps, toothpaste, and, not vegetables are perishable goods, but, other day-to-day goods. For those, you will need a long-term forecasting, right? So the aim for these forecasting is different for each of the time period, right? So in medium forecasting, the more emphasis is on the budgets, and the main aim for the forecasting, or the objective for forecasting will be to emphasize on the budget and such kind of other factors. But mostly forecasting, we do for mainly working capital, to manage the working capital, manpower, to decide on the manpower, how much manpower is needed, and for machine hours, budgetings, and all of those, machine availability, for all of those things. So unless and until you know how many goods you're manufacturing, you cannot come to a proper estimation of this. So suppose you are manufacturing 100 goods, so there'll be a fixed amount of raw material required, right? So raw material and number of labor hours required, the number of machine hours required, the number of machine hours which are required for manufacturing. So all of these, we can estimate these with the help of forecasting only, right? So this is the main aim for forecasting the demand, right? So there are several methods for demand forecasting. Okay, so you will have qualitative method and quantitative methods, right? So Okay. So what is qualitative method and what is quantitative method, right? So qualitative method, it is nothing but, it is a market, survey. So this is a statistical or, mathematical analysis. This is statistical or mathematical analysis, okay, of the forecast. So you will be using, statistical methods, and you will be using equations and more. It's more of a, it is based on the historic data, right? So this is based on the previous history. Right. And what is qualitative? So qualitative is nothing but it is a process. So you go into the market and you survey, you conduct market surveys. You might go to your distribution centers, or you might go to your shops and your wholesale dealers, and you conduct a survey, and you can conduct the survey of your customers as well. Okay. And you will have expert opinions. So there'll be market experts, so you can get those opinions, or you can get a view of your leadership teams. uh, there are leadership teams within your organization. So all of this is it is morely an opinion and a gathering of data, right? So this is a gathering of data from different sources. So that is the qualitative method. And in the quantitative, it is basically loosely based on the statistics. So you study the previous history, so maybe you study the history of the past 5 years, or the past 4 years, and then based on that, if you find any pattern, so basically you want to make a pattern out of it. So if you see that every year your sales is increasing, okay, and last year every year sales is increasing by 5%, okay. So last year your sales was 100 1 crore 100 lakh units, right? So now if somebody asks you what will be the sales of my next year, then because you have already observed that every year my sale is increasing 5%, so it will be 105 for the next year. So this is a kind of a analysis. So this is a kind of a pattern which you have observed over the year, and then basically you are assuming that the same pattern will continue, and your sales will be according to the pattern which you have observed, right? So these are the two methods of demand forecasting, right? Okay, so mostly in this chapter, we will be dealing with quantitative methods, which is a mathematical modeling and statistical modeling. So we will be dealing with quantitative, and if you have observed your previous question papers, right? So there will be questions from this based. It will loosely be a time series question, or a quantitative trend. They'll ask you a trend, right? So. Coming to quantitative models, okay. So quantitative model, you have a trend analysis, right? So there's a trend analysis. So basically, what is a trend? A trend is something where, as we were discussing previously, so there is some kind of a relationship. There is some kind of a relationship between two units. So suppose say time and your sales, right? Now I can say that every year, so suppose let us say from 2015 we are taking, every year my trend says that my sales is increasing 5%, right? So this is a trend. So 2016. So suppose you have 100 here, you'll have 105 here, right? And 2017. So you'll have a 5% increase there. Okay. So 5% on 105, right? So that is a trend. So this is a linear equation. So you are saying this is my time and this is my sales, right? So every year, so you can take 2015 as your 0, and then this will be 1, 2. So every year you have a sale. This is a trend, right? This is a trend. Okay. So trend basically consists of 4 components, right? A trend consists of 4 components. Okay. So this is a time series consists of 4 components. Time series is a quantitative method. So time series consists of 4 components. Let me just clear this. Yeah. Time series consists of 4 components. Okay. One is a trend, which we were talking about. Second component is your seasonal. Third component is your cyclical. And fourth component is random. Right. So as we were discussing trend, we said that there's some kind of a causal relationship between the time. So it might be increasing, it might be decreasing, it might be even constant also. So constant is also trend. So it says that there's no change in the time, right? So if you have 100 units you're selling and you're selling 100 units throughout 3 years or 4 years, there's no change. So even a flat non-increase or decrease is also a trend. And seasonal. So seasonal, if you see, there are many seasonal goods, right? Can you give some examples of seasonal goods which you know find more in any season? Seasonal goods, so say crackers, right? Crackers you will only buy using Diwali time, right? You will not buy it throughout the year, right? And you can say clothes. Clothes also using festivals. People generally buy new clothes for festivals and all of those kind of events, right? Okay. So yeah, things like this. So things like this, we can say that there's a good trend in seasonal. So the sales of crackers and clothes, it peaks during the your festivals and all, and then again it goes down, right? So this is one factor in the time analysis. And then there's cyclical. So cyclical is nothing but cyclical. We can say it is something called a macroeconomic factor. Okay, so what is a macroeconomic factor? So in economy, in economics, there's a concept called macroeconomics. So macroeconomics is nothing called, it is, nothing but it is as a whole. So either at a country level or, at a global level, right? So suppose macroeconomic factor, which we can say, so a very relatable example will be your home loan rates, right? So it is nothing but, so RBI has something called a repo rate, right? So you might have, if you follow the news, you will be, getting across these terms called repo rate. So what is repo rate? Repo rate is something that, banks lend to each other at that rate, right? So all your home loan rates and, your vehicle loan rates, or all these rates are dependent on this repo rate. Now, if you see, if the repo rate is lower, right? If the repo rate is something, very low, say suppose it is 3% or something, okay? So if it is 3%, then the home loan is probably available at 5%. Now suppose this is a very cheap rate, right? So if the rate is so cheap, people will be motivated to buy homes because it is coming at a cheaper. The EMI will be less, and then they can buy. So this is a macroeconomic factor. Okay, so IBA rate. Now suppose IBA rate is very high. Suppose it is say 9%, and your home loan is like 15%. Then at that point of time, people will not be able to afford homes, right? So this is called a cyclic factor. And you can macroeconomic factors. There's something you might have heard the term recession, right? So recessions and depressions and all of these things where there's not a lot of free money flowing into the market. So this is one factor in determining your demand. So at these kind of depression periods, you will not have much of a free money or disposable income. So that at that point of time, your sales and all of this will be at a low compared to the normal thing. And random. So these are all logical, but random is something which you cannot foresee, so which you have not imagined or which is not existent. So suppose you can take an example of COVID. So COVID, nobody saw, nobody foresee what happened in COVID. So in COVID times, what happened? So hospitals were full, right? People were getting admitted. There were no beds at that time. So something like this, some unforeseen event, so nobody knew that something called COVID, would come, and then so something like this, which nobody can estimate prior hand. This is a random factor, right? This is a random factor. So all of these, together, will affect how you forecast your sales. Okay, right. Now in time series, you have two models. You have additive model and you have multiplication, and you can have you can play around it. There's no fixed theory, so whichever fixed, so they can be a mixed model as well. Okay, so what is additive model? So in additive, it is nothing but your trend plus seasonal plus cyclical plus random. So this is your time series, right? This is your additive model. So you say that your forecast is a sum of all of these factors. Okay. So what is it in multiplication terms? So in multiplication terms, it is T into S into C into R. You can have mixed also. So if you say that my trend is not actually following this model or this model, so we can do an analysis and we can say, okay, so it is maybe probably T into S plus C plus R, something like that. So this is just an example, right? So you can multiply and then you can have a sum, or you can have three factors in a multiplication, or that is a mixed model, right? Excuse me. Yeah, so these are the different kind of models in your time series. Okay. Yeah. Okay. So now, as we were discussing about trend, right? A trend, we can, something that follows a linear method. So, if suppose you have a graph like we were discussing, this is your sales, this is your time. So this is called your x-axis and this is called your y-axis. So you are aware of that, right? So in a graph, this is x-axis and this is your y-axis. Now suppose for 1 year, for first year, your sales is here, right? Your second year, your sales is here. Your third year, your sales is here, right? So this, if you can plot it on a straight line, right, this is called a linear model. This is a linear model. Not only a straight line, but something which you can fit in an equation, right? So now suppose you have one more model, which is like this, okay? So this is nothing but this is a parabola. As in your sales, it gradually started increasing and now it is exponentially increasing. But still you can represent this in a graph and you can give it, an equation form. So even this is a linear model, right? So this will be this. So you will have a data. You will have the data of, suppose, time, as we were discussing, year versus sales. You will plot that on a graph, and when you plot that on a graph, and if you can, come into some, if you can just come in some form of an equation. So the basically, equations are of many types. So for a straight line, in case of a line, okay, for a line, the equation is, it will be y equal to, a plus bx. So y is your y-axis and x is your x-axis. So if it is a parabola or some kind of a curve, it will be y equal to a plus bx plus cx square, right? So if your points are, fitting in this kind of equation, then you can know it, and you can, even have exponential graphs also. So exponential will be something like, like this. So both sides it will be like this. So that will be y equal to e to the power of x. This is exponential. Basically these are computer models, okay? So physically we cannot plot it, but with the help of computer modeling, we can, we can come with some sort of an equation. If it fits, that's a linear model, right? And mostly in our syllabus we have linear model in terms of a line, right? So we have a linear time model, okay? So in a graph, yeah, so this is a line, okay? A line always, this is your x-axis and this is your y-axis, right? A line always follows this y equal to a plus bx, this equation. So a line always follows this equation. This is the equation of a line, right? This is called your slope, okay? So b is called your slope. Slope is nothing but, the, technically speaking, slope is the angle between the x and your line, the x-axis and the line. This is the angle. So it is a tan theta. We do not know, there's no need to go into that detail of mathematics, but we have to know that this is the equation of your line. Y is equal to a plus bx, right? Okay, so if you have some kind of a data, let me take an example. So let us have a table. This is y, okay? So this is our equation, okay? So and this is your this is line. So for y1, your trend would be a plus bx1. Or if you take a time series analysis, okay, so x is nothing but t. So in this example we can say we are trying to find sales in respect to time, right? So for each year, what is my sales volume? So that is what we are trying. If we are trying to find out that, then it will be a plus, we can write it as bt. Just instead of x, we know the variable as time, right? So this will be t1, okay? y2 equal to a plus b t2. So you will have so on. This will be the data. For different values of y, based on the time, you will have your sales. So this, we can say this is a sales in our example, right? So if you sum this, this will be y1 plus y2 plus y3 and so on. And this will be, so suppose you have up to yn, okay? So this will be up to yn, n number of items, right? N number of, you can say, years, right? Then you will have, this will be a into n, because you'll have 1 2 3 n times, right? Again b into, you will have t1 plus t2 so on to tn. Okay, so this you can write as sigma of y. You know what sigma is? Sigma is nothing but a summation. It just represents a summation. Okay, summation of y equal to an plus b sigma, right? So this is the time. So we are having the deviation of time, and then we have the sales. This is the sum of, this is the sales. Okay, so this is one equation, you know. This is an important equation. Equation 1, okay. Similarly, we have, if we just further, you know, analyze this our table y and then sales, okay. So here what we will do, we will multiply both sides by time, right? So this is y equal to a plus bt, right? Now I want to multiply both sides by time. So this t1, I'm not doing anything, I'm just multiplying this by time. So I'm doing just ty at plus bt square, both sides, right? So I'm doing this throughout. Right. Now if I sum this, so this will be my t1 y1 plus t2 y2 plus so on. So I can write this as sigma ty, right? This is equal to nothing but my a sigma t plus my b sigma t square, right? So this is my second equation. So we've got two equations, right? First one was my sigma y equal to a plus b sigma t. My second equation was sigma t y equal to a sigma t plus b sigma t square. Okay, this is my equation 1 and equation 2, right? Okay. Now in a time series, Okay, so this is our sales with respect to time, right? In a time series, if we think about what we are doing, this sigma t, if we analyze, sigma t is the deviation of time. So sigma t, so if I am saying my year 1 equal to 2020, my year 2 equal to 2021, now what does sigma t mean? Sigma, I cannot just add years, right? It doesn't make any sense. We cannot add the years. So this is called a deviation. Okay, deviation in time. Okay, so what I will do, I will assign, so if I have 3 years, 2022, right? I have 3 years. I will have to assign numbers to these years such a way that the deviation, the sum should, so it will be 0. So I will say this is my 0th year, right? This is my 0th year, and this 2022 will be my +1, and this will be my -1, right? So now if I sum, it will be 0. So it's in a time series, sigma t is always 0, right? This is only in case of a time series. In time series, sum of my years is equal to 0, right? This is in time series. So I am analyzing sales with respect to time, right? Now suppose if this is not time, if I am analyzing a variable y with respect to a variable x, then sigma x is not 0, right? Because I do not know what x is. Maybe sum of x might not be 0. It is some other variable, right? So as in a time series, my sigma t equal to 0. So what will be this one be? This is na, I'm sorry, right? Number of rows it was there, right? So in y equal to a plus bt, which is the equation, I can say a equal to, if I substitute 0 in my equation 1, so this is 0, right? So a will be my sigma y by n, right? Because this is 0. Now same thing, if I do it here, this is 0, right? So my b will be sigma ty by sigma t square. In time series, yes. In time series, sigma t is 0, correct. Okay, so in a time series, my a value is this and my b value is this. Okay, so this is very important for solving our problems. So we have to remember these equations, right? These equations, and these are specific time series equations. Okay, this might be a little confusing, but if we will, yeah. The first equation, previous. First equation, I have just summed y and this, and I have got sigma y equal to a into n number of items plus b into sigma t. And the second equation, I have just multiplied this by the time range, right? So I got sigma t y equal to, I have multiplied it on both sides, and then I've got sigma t and b t square. So these are my two equations. प्रॉब्लम में आपको समझ में आ जाएगा because this is a time deviation. With respect of time deviation, we are taking the sale, right? So that is why. Okay, so we can take a look at one time series problem. Yeah, you can go to page number 28. Okay, we have here and yeah, so we have a year and we have a sales, right? From 2015 to 21. Okay, you have your sales value. This is sales in 1000 units, huh? Okay. Okay. So if you look at the question, he has not given, yeah, he says from the following time series data of sales project, the sales for the next 3 years. So we have to find the sales for the next 3 years, right? So he has given till 21. So we want sales for 22, 23 and to the 24, right? So this is what he has asked us. Now, okay, so he has not given it as a linear, but we have to assume it that this is a linear time series, right? So linear time series follows this pattern, right? Did I take it correctly? Yeah, 1, 2, 3, yeah, 7, fine. Okay. So in okay. So as we have seen in while deriving our equations, so this is a time series problem. So we want sales as a function of time, right? This is sales as a function of time. And in a time series problem, we have to have sigma t equal to 0. So generally what we do, because this is an odd number, right? So you can pick the middle element and you have to give it a value of 0. So this will be t and 0, right? And this will be 1 year prior to that. This is -2 and this is -3. So this is +1, this is +2 and this is +3. So you are required to find the data for +4, +5 and +6. And this is my sigma t. My sigma t is 0. Okay. Okay. So now to derive this time series equation, so we know y equal to a plus bt, right? And we have seen a equal to, and the time series a equal to sigma y by n. This is equal to my sigma y by n. Okay. So my n is 7, right? I have data for 7 years. So let us sum our sales. So how much is the sum? 630, right? That's correct. Shall we can calculate 80, 90, 92, 83, 94, 99 plus 92. So this is 630, right? So my sigma y is equal to 630 and my n equal to 7. So the value of my A is 630 by 7, which is 90, is it? Yeah. So this is my A, right? Okay, I'll just erase this part. Now we need B, right? So B is nothing but summation of, yeah, that is summation of my time and y divided by t square, right? So let me have ty and t square over here. I'm erasing this part. If you are noting down, please note down this part. I'm erasing. Yeah. So t into y minus 240 minus 180 minus 92, this will be 0, 94 will be my 18, 198, is it? Yeah, 98, 6, 276. Yeah, okay. Yeah. So now the sum of this is 56. Okay. T square is nothing but t into t. So this is 9, 4, 1, 0, 9, 4, 1. That would be 28. Yeah, 14, 14, 28. Yeah. So now A we have already calculated as 90, right? Now coming to B. So B is 56 by 28. That is 2, right? Oh, sorry. Right. So in my equation y equal to a plus bt, so y equal to 90 plus 2t, right? This is the equation. Okay. So now we want sales for 2022, 23 and 24, right? Yeah. So for 2022, my y22 will be nothing but 90 plus 2 into, so this year 21 is plus 3, right? So this will be 4. And my y2023 will be 2 into 5. To 6, right? This is 98, this 100, this is 102. Understood? So yeah, no, तो correct, that's a good question. तो अभी आपके पास you have 7 elements, right? तो आपने 0, -1, 2 and plus में you have got it. abhi if you have 8 elements, then you have to get summation t equal to 0. So how will you do that? If you have 8 elements, you cannot give 0, so you cannot get that way, right? So if you have 8 elements, so if you look at the next question आप देखिए, इसमें you have 6 data, right? So here there is no middle term for you to assign 0. So the middle two terms you will isolate, and then you will give +1 and -1, right? So huh? Yeah, middle term as 0. And if you have even terms, so if you have 6 period, 1, 2, 3, 4, 5, 6, so you will take 3 and 4 and you will assign +1 and -1 and -3, because there's a 2 difference here, right? So you have to carry the 2 difference, because the difference should be there, and you have to sum, you have to get 0 in a time series, right? So for even, you have to for even number of data you have to follow this, and for odd number of data, for the middle element you can assign 0, right? For middle element you will have 0, here you will have -1 and +1. Okay, so this problem you do it as a homework. Okay, you do, and if you have any questions, we'll discuss it in the next class. Okay, now we will see one more type of problem. Which is a non-time series problem, right? So in a non-time series problem, you will not have sigma t is 0. This assumption will not hold good, right? So this assumption will not hold good in a non-time series problem. So in non-time series problem, it will be y equal to a plus bx. Okay. So if we take a look at our problem, go to page number 30, illustration number 3, right? So here, if you see the data, he has given you the population of a time and the number of TV sets at that population, right? So he says when there are 5 lakh people in the town, you had a demand of 9,000 TV sets, right? So in this case, this is not a time series problem. So you do not have any year analysis, and you cannot say that my population summation should be 0. That doesn't make sense at all, because population summation is never 0, right? So in this case, your sigma t equal to 0 will not hold true, right? So if you go back to our derivation of the equations, we could get a and b equal to this only by assuming sigma t equal to 0. But in my current case, I have two equations. Sigma t is not equal to 0. So I have equations saying sigma y equal to na plus b sigma x. So this will become x. And then sigma xy equal to a sigma x plus b sigma x square. Right. Okay, so let us solve one problem. Let us solve this problem. Right. So we will have an understanding. Let me erase all. Excuse me. Yeah. So let us make a table x. Okay. This is 5, 7, 8, 11, 14. And y, this is the population. And this is the TV. And one more thing is, you first read the question very carefully. Here in the question he has given you x and y, but you have to, if he doesn't mention what is x and what is y, then we have to be in a position to understand what is x and what is y. Now see, here he clearly says that fit a linear regression of y on x. So of y on x means y equal to a plus bx. Okay, right? And he also says estimate the demand for CCTVs for the two towns with population 10 and 20 lakhs, right? So population he has given, he wants us to find the number of TVs for those population, right? So this data, if you see, this is 9, 13, 11, 15, and 19. Okay. Yeah. So if you remember the equations, Our equations were, let us look at our equations. Yeah, first equation was sigma y equal to Na plus b into sigma t, right? Yeah, so sigma y equal to n into a plus b into sigma t. So this is actually x, not t. Yeah, and my second equation was sigma xy equal to a into sigma x plus b into sigma x square, right? You can take a look at that. See, t is replaced by x, so xy equal to a sigma x and b sigma t. Okay. Yeah. So now, so my sigma x is how much? 45. Right. Okay. And my n is my sample size, that is 5. Correct? Yeah. And then sigma x we've got and sigma y. What is my sigma y? 67. Yeah. What else do we need? We yeah, so we will have xy here. Let us multiply these two. This is 45. 13 sevens are 91, 88. This is 165 and 19 14s are 266. Yeah. Now sigma xy. This is how much? 655. Okay. Now we need x square. Right. That is 25, 49, 64, 121, 14 is 196. Right. So my sigma x square is 455. Yeah. Okay. Now we have to arrive at a and b, right? If we arrive at a and b, only then we can find out. So what does he say? He says find out the number of TVs for a population of 10 and 20 lakhs, right? So he has given me the value of x. So he is asking me to find y when x is equal to 10 and when x equal to 20. So what is y? So that is what he is asking me to find, right? Okay. So let us plot our values in the equation. So my first equation will be sigma y is 67, right? 67 equal to 5a plus b into sigma x. What is this? 45x. Yeah, 45 into b, right? This is my first equation. And my second equation will be 655 is equal to 45a plus 455b, right? So this is my two equations. So this is called quadratic equations. So you know how to solve quadratic equations? Okay, so basically in this thing I can just multiply my first equation by 9, right? So that I'll get 45a in both, and then I can subtract the equation. So if you do that, what is 67 into 9? Let us use a calculator. So you are allowed calculators in the exam, right? So yeah. So this is 603 equal to 45A plus 45 into 9, 405B. Okay. Now I'm subtracting these two, this minus this. So this is minus, this is minus, and this is minus. So this gets cancelled. So I have 655 minus 603. That comes to 52. 52 equal to, I have 455 minus 405, 50B. Right. So I've got my value of B equal to 52 by 50. That is, yeah, 1.04. Now similarly, if I just plot this 1.04 into any of my equations, you will get the value of A, right? So let us plot it in my first equation. So 67 equal to 5A plus 45 into 1.04. 46.8, right? Okay, so from this I will get A as 67 minus 46.8 divided by 5, right? That is 4.04. Any questions how I got these values? Okay, so I have got my quadratic equation, right? So I've got the values of A and B. So my y equal to, what was A? 4.04, right? 4.04 plus 1.04b, correct? So this b is nothing but x, not is x, sorry, yeah, x. Okay, so y equal to a plus bx is our equation, and we've got 4.04 plus 1.04x, right? Now let us find out the value of y for 10 lakhs population. That is 4.04 plus 1.04 into 10. That is 10.4. So how much is that? $14.44, right? So this is 14.44. The units were in thousand. So 1000. So into 1000 you have to do. So many TVs are required for 10 lakhs population. And the next one was 15 lakhs, is it? 20 lakhs. So for 20 lakhs it is 4.04 plus 1.04 into 20. So that comes to 24.84. 24.84 into 1000 TVs. Okay. So the main equations which you have to remember, right? These are main equations which we have to use to solve any linear time series problem, right? Okay. Linear time series problem, and in the case of a time series, so this is a trend, I mean, and in case of a time series, sigma t is equal to 0, so you can directly plot the values of A and B using this formula. This is only in the case of a time series, but if the time is not there, if it is in relation with something, then these equations will not work. You have to derive the value of A and B from these equations. Okay? You understood? Any questions? No? No? So we will stop here for today, right? And there's one more problem. So please do illustration number 2 and number 4 as a homework. Okay? So illustration 2 is a time series problem, and illustration 4 is a similar problem, a non-time series problem. Okay, you kindly do those two as homework, and if you have any questions, we can discuss it in the next class. Okay? Yeah. Thank you.